Hello, and welcome to Section 4 of the Hidden Risks of Green Buildings course. The objective for this section is to determine a solution for addressing the risk factors of introducing ventilated air into the building envelope. The focus of Section 4 is to take an in-depth look at the intent of providing additional outdoor air ventilation to improve air quality for improved occupant comfort, well-being, and productivity. For decades, there have been competing arguments within the mechanical design community on whether to increase or decrease the amount of outside air that is introduced into commercial and institutional buildings. Although there are sound arguments on both sides of the debate, today's emphasis on increased building ventilation to achieve LEED credits has given an added incentive to increase the amount of outside air into buildings. The experience of many forensic building experts, especially in the eastern half of the country, do not necessarily support the theory that adding more outside air creates a better performing, more sustainable building. Sometimes quite the opposite. What is known about ventilation air is that in regions with ambient high dew point conditions and elevated relative humidity levels, which include much of the entire eastern half of the country during portions of the year, there is a direct correlation between the number of moisture problems and increased rates of mechanical building ventilation. This can occur for obvious reasons, such as the additional moisture load that is introduced into the building along with the outside air. However, more obscure reasons can also increase the risk of adding outside air to a building. Unbalanced or partially depressurized buildings can be the result of moving large amounts of air around a building. When this condition occurs, moisture problems become more prevalent. These unbalanced conditions happen when air is trying to flow from the supply side of the air handler equipment to the return side, but is restricted by structural or architectural barriers. Florida Solar Energy Center of Cocoa, Florida, called this condition the smart air syndrome concept, in which air is supposed to be smart enough to get from one place to another in spite of barriers. Additional ventilation air should always be designed in conjunction with considering the impact of the distribution of the ventilation air. This requires identifying the parts of the building that could become depressurized with respect to outside conditions, thus potentially drawing humid outside air into the envelope cavity or occupied spaces. Even in less humid climates, an unbalanced heating, ventilation, air conditioning system can inadvertently transfer odors and airborne pollutants in unintended ways throughout a building. This increased risk of moisture problems caused by greater air volumes and thus unbalanced areas of the building is depicted in this Florida Solar Energy Center graphic. Florida Solar Energy Center's research has demonstrated the relationship between building complexity, architectural and structural, the intensity of the heating, ventilation, air conditioning drivers, air volumes and pressures, and the risk of building failures. The solution is not to build simpler, less ventilated buildings, but it is to ensure that the ventilation air is effectively delivered to the space. This means that ventilation must be distributed so that it not only reaches the desired breathing zone, but does so in a manner that does not adversely affect the building. The heating, ventilation, air conditioning system that introduces ventilation air must also do so in a manner that properly dehumidifies the air. The golden rule of moisture control is that under no circumstances should adequate dehumidification be sacrificed for increased ventilation. In many regions of the country during summertime conditions, the moisture load contributed by the outside air can exceed the amount of moisture that the air conditioning system can effectively remove. The solution is to address these risk factors in specific ways. Ensure the correct distribution of airflows within buildings to avoid pressure imbalances. This can usually be accurately predicted during design. Increase the verification of heating, ventilation, air conditioning system performance by adding additional elements to the building startup and commissioning programs. This post-construction verification includes detailed pressure mapping of the building to confirm proper air distribution and using temperature and relative humidity data loggers to confirm conditions during the first year's operation. The pressure mapping and data logging needs to also include the building cavities, areas that are often ignored. Many of these elements are frequently absent in today's standard heating, ventilation, air conditioning system startup and building commissioning programs. What experience demonstrates is that increased amounts of outside air can be safely added to a building if the known causes of increased risk, such as proper air distribution, are addressed during design and verified after construction. This ends the Section 4 learning content material. Please proceed to the self-assessment for Section 4 or review the section video again.